Now take this question. In this two circuits are given and we have to check validity of Thevenin and Norton theorem for these two circuits. First take this circuit. Here in this circuit, what is RTH? So to find the RTH we have to open the current source and we have to sort the voltage source. So we will get circuit like this. So it simply shows that RTH is equals to 0. And what is VTH? We know that voltage across this terminal AB is equals to this voltage V because they are in parallel. So VTH is simply equals to V. Okay. And what is Norton current? IN is equals to V by R. So VTH by RTH. So it is equals to V by 0, which is not defined. Here you must know that the value V by 0 is not defined. That's why for this circuit only Thevenin is possible. Okay, and Norton is not possible. Now see this circuit. Here for this circuit we have to find the RTH. What is RTH for this circuit? See, to find the RTH we have to sort the voltage source and open the current source. In that case this RTH will be equals to infinity. Okay, because it has infinite resistance, that's why it is open circuited. Now what is value of voltage across this? We cannot find the voltage across terminal AB because this voltage source is in series with this current source. So we cannot find VTH. And what is IN? So how we find the IN? We find the IN if we simply sort this terminal AB, then current through this branch is equals to IN. If we sort this, then current in this branch will be equals to this current source I. That's why IN is equals to I. So for this circuit, Norton is possible. Okay, while Thevenin is not possible. Okay, and for this Thevenin is possible, Norton is not possible. Now see this question that has been asked in ES 2016. Here in this circuit, this 30 volt source is given and these 3 ohm resistances are connected in parallel, and we have to find equivalent resistance across terminal AB. So see how we can find the equivalent resistance. To find the equivalent resistance, what we have to do, we have to short circuit the voltage source. So when we short this voltage source, then we get equivalent resistance is equals to 0, because all these 3 resistances are in parallel and this whole combination is in parallel with the sorted path. It means equivalent resistance will become 0. Now see this question that has been asked in ES 2013. Here this is network and this has voltage V across terminal AB and this is the current I. VI characteristic is shown here, and for this characteristic we have to find the value of VTH and RTH. So we know that VTH is the open circuit voltage across the terminal AB. It means it is the voltage across the terminal AB when these terminals are open. In that case, when these terminals are open, then this I is equals to 0. So here from the characteristic we can see that when current I is equals to 0, then voltage across terminal AB is 25 volt. It means VOC, that is open circuit voltage, is equals to VTH is equals to 25 volt. Now second is, what is Norton current IN? Norton current IN is equals to short circuit current which flows when terminal A and B are short circuited. So when we short circuit these terminals, then current flowing through this terminal AB is called Norton current. So how we can find Norton current? When we short this terminal, then voltage V becomes 0. And what is current flowing through this terminal? That is equals to minus I. So when this terminal is shorted, then V is equals to 0, and at V is equals to 0, current is minus 5 ampere. So Norton current is equals to minus I, that is minus 5. It means Norton current is equals to 5 ampere. Now what is value of Thevenin resistance? RTH. It is simply equals to VTH, V by IN. And what is VTH? That is equals to 25. And what is IN? That is equals to 5. So we get RTH is equals to 5 ohm. Now see this question that has been asked in IES 2014. Okay, a battery drives 5 ampere current into 1 ohm resistance at its output. If it is able to charge an ideal 2 volt battery at the rate of 7 ampere, okay, then its Thevenin equivalent will be. So here we have to find the Thevenin equivalent of battery. Suppose battery has voltage V and resistance RTH, okay, and it is delivering current to this resistance R. So take the first case, a battery drives 5 ampere current. It means current is 5 ampere and resistance is given 1 ohm resistance. So for this case we can write VTH is equals to 5 RTH plus 1 into 5. This 1 is the resistance R and 5 is the current. So from this we get VTH is equals to 5 RTH plus 5. Now take the second case. If it is able to charge an ideal 2 volt battery at 7 ampere rate, it means current here is given 7 ampere and voltage across battery is given as 2 volt. Now we can apply the KVL. VTH is equals to 7 RTH plus this 2 volt. So we get that two equations and two variables, that is VTH and RTH. So when we solve this, we get VTH is equals to 1.5 ohm and VTH is equals to 12.5 volt and RTH is equals to 1.5 ohm. So this is the answer of this question. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.